Welcome back to yet another episode of Making Mario in JavaScript. Today we're going to focus on making entities become a little bit better to load and spawn. If we open up the code here, and we look at our main method, we can see that in order to create Mario, we just make one asynchronous call. And that's pretty awkward. This makes sense because we loaded an image, and that's kind of how this project started. But imagine you want to create a lot of Marios. Then, we would have to have some weird promise here that resolves at a frame we don't really know when it happens, and that would be super weird. Imagine I want to add a trait here to Mario. So Mario.add trait, and I'm just gonna fake a trait here. Mario delta time. And every time Mario jumped, he created new Marios. Then we say Mario.velocity.x is less than 0. And an if statement here. Then we wanted to create more Marios. Then we would have to do something. Create Mario. Then level.entities.add. So you see what would happen in this case. We would have the update method go in here. And then we would ask to create a Mario, and we didn't know exactly when we insert it to the level. If we want to spawn objects, we need to do it synchronously. So today, it's all about making the entities be spawnable synchronously. So let's delete this example code here. And get started on this amazing task! Oh god, I think my voice is acting up. I'm gonna have to have some tea here. So, first, I'm gonna go in here to the entities.js file, and I'm gonna move this into its own module that is called Mario. I'm gonna save a copy of this in a folder called entities, and I'm gonna name it Mario.js. The reason I have a big M here is not exactly clear. But it feels right. Complaints can be sent to the complaints department on this. So what we have to do here now is update these imports, because we moved them up a folder, so we need to look for them down a folder. Then in the main, we need to update the createMario. And that is now in entities/mario.js. Since this is now technically a loader, just like load level, I'm gonna rename it so. So create Mario is gonna be load Mario. Let's save this and update the export. So now we establish a little rule here in our game that load functions are asynchronous, but create functions are not. So that's just a little naming convention we agree on here. Before we're gonna act up more, let's make sure this works. The easiest way to make this synchronous is that instead of returning a Mario, we return a function that creates a Mario. So the absolute simplest version, without using any cleanups before, would be this. And we indent this. So, when load Mario is run, we load a sprite sheet. When we have the sprite, we return a function that creates Mario. So this function is going to be completely synchronous. In order to use this, we need to update main. So instead of getting a Mario here, we're going to get a function that is called createMario. So the next step is to create Mario here. Let's see how it goes. It works the same. Now let's try out that trait idea I had. So I'm gonna do a little bit hacky thing here. I'm gonna add an anonymous trait to Mario here. Mario.add trait, and I just hack together a trait here. It has an update method that we get out Mario in, we get out delta time, and we also need a name, I think. name like this. We can just call it hack trait, doesn't matter. Then we need to define an obstruct method, and we don't have to do anything in that, I think. Here on the update, whenever Mario is jumping up, we're gonna spawn more Marios. Let's see if it works. I have no idea. Okay, let's see if we do it now. Whee! Whee! Okay, that was way too many. We need to have some exception here. Then we set this a spawn timeout to 0. And in down here we set a spawn timeout plus equals delta time. So now we won't go as crazy with this spawning thingamajig here. More! That's more velocity. It should be this. Why here should be that? And hey ho! There we go. Now it looks like fun. Now we're having fun. Yippee! We're spraying Mario all over the level here. Blah, blah. It's like he's barfing out himself a little bit here. Blah, 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 blah. Okay, I think I made my point. Spawning synchronously is good and fun. So now, back in Mario.js, let's make this a little bit cleaner here. So this thing is gonna be moved out, and we're gonna put it down here. And we're gonna name it appropriately. No, sorry, we're gonna wrap it in a function. And this function is gonna be called createMario function, createMario, and it takes the sprite sheet, and it returns a createMario function. There we go. Yeah, these are tricky to get right, especially with item accumulation. So we have the createMario here. It takes a sprite, and this gives a sprite, so we can just put that name here. Well, let's make sure we didn't destroy anything. There we go. So this works now, and Mario can be created synchronously, and the code is not awful to look at. But we have a little thing here that we can improve, and it is that this animation and this route frame function, it is created from scratch every time we create a Mario, and that is not needed, because both runAnim and route frame, it's completely stateless. It just looks at the Mario object and it returns a string. So look at this here. If I log out here, console.log, creating support functions, and then I go into main here again, and I re-enable the spawning. So we create the support functions once. Let me zoom in this a little bit because this is really, really important. There we go. That's the zoom level of high importance. So when we load the game, press F5, we're creating the support functions. Then when we spawn, we're creating them again. So we're recreating these support functions for animation, and for animation only actually, every time we create a Mario. And this is complete waste, because they don't change, they don't take the information from the context, they are just pure functions, so we can reuse them. So let's reuse them. Go back here into Mario.js, and this is as simple as just moving this out to the factory scope. So look at this. Here is the factory scope, and the factory is the function that creates the createMario function. Or sorry, this is actually factory. And the factory scope is this. It is the function that creates the factory. While this is, this is actually the factory scope, I guess. But anyway, this is the create function for the factory, and this is the create function for Mario. And we really only need these functions to be created outside here. So let's copy this. No, I'm gonna cut it out actually. I cut that out, I paste it in here, and I fix the indentation. And let's run this again. So we create the support functions when we load the game, but we reuse them throughout the game. So this saves a little bit of memory. And saving memory is just nice. None of these functions actually use anything inside this function either, so we could move them out here even. created once when the game starts, but not again. But, and this is a dumb but I'm going to leave them in the factory for now, because I think it makes a little bit more sense, and we still have control over this because we know exactly when we create the Mario factory. This is just something we do once by the code design. So now we have saved up a little here, so we can remove this console.log. But there's actually one more thing we can put in here, and that is the turbo function and the draw function. So let's copy them out here. Set turbo state to turbo on, and draw Mario and draw him on. So we put that here, fix the indentation, and now we can just assign these functions to Mario instead. The say turbo is set turbo state, Mario.draw is draw Mario. And let's make sure we didn't die. Hooray! And we create Marios and everything's good. You know what fun thing we can do now? This animation can be parsed from the sprite JSON. So if you remember earlier, in Underworld or Overworld here, we added animations down here. And this is the exact same animation that we create in here. So let's have some fun with this and go into our Mario.json and just paste a little bit in here that I prepared from earlier. So I paste in an animations definition for run with the framing 6 and run 1 here. If we go back here now to Mario and we log out sprite, what we have in here now is an animation called run that is a function called result frame. So now we can just say const run anim equals sprite.animations.get run. Let's try this. Slutade koda. So here we go. And now we just have the animation inside the sprite JSON too. Isn't that nice? So let's throw out createAnim here and do one little nice thing. Instead of assigning Mario.go.drag factor here, we're gonna call turbo with false. So Mario.turbo and false. So basically what we do here is initialize Mario to make sure that turbo is false instead of assigning this.go.drag factor. Because this is a turbo state's function's job to assign what speed it is, so you shouldn't duplicate that logic. Now we're going to add a Goomba. So I'm going to take this Mario.json and I'm going to save it as Goomba.json, and I'm going to paste in some preparations I have here. So here we simply have from characters.gif. Let's have a look at this file actually. So we have these 3 Goomba frames defined in this file. We have walk 1, we have walk 2, and we have flat. Then, just like with Mario here, we're gonna create a Goomba.js. So I'm gonna save this as Goomba.js. And I'm gonna paste in some code I prepared. There I pasted it. So this have the same, what do you say, profile as the Mario file. It has a load Goomba function that loads the Goomba sprite sheet that we have saved here. Then it runs create Goomba factory, which creates a create Goomba function, and that function returns a Goomba. This new nice load Goomba function we can put in main. So let's import it up here. And the Mario becomes Goomba. Make sure we load Goomba here, and we get out a create Goomba function. I'm gonna remove this old Mario hack trait, and instead I'm gonna create a Goomba. So const Goomba equals create Goomba, and the position could be Goomba.position.x equals 220y, 220y, and then we add it to the level.entities.add Goomba. So currently I'm apparently living under the airport. There are planes landing very often this time of day. Let's see if we have a Goomba. No, we have an explosion, an unexpected token. Yuck. Let's see what we got wrong. Yeah, we got the name of the file wrong. Pretty embarrassing, but easily fixable. Let's see here. Here's a Goomba. Good start. Let's see how we can make Goomba move. In Goomba.js, we're gonna set a little velocity on Goomba. So Goomba.velocity.x equals -30. Okay, that's a start. What we want to do now is enhance this a little bit. We want Goomba to walk into the wall, then turn around. So that is the Goomba behavior. It's gonna walk into the wall, doink, and then it's gonna turn around, walk into another wall, and doink, and continue that. Let's see if we can get this started. In Goomba.js here, I'm gonna start hacking away at a trait. We're probably gonna make this trait real, but for now I'm just gonna write it inline here in the file. So Goomba.add trait, and the name is gonna be walk. The speed was pretty good, I think, so let's set that to -30. Then on updates, we're gonna set the velocity on Goomba to speed. So Goomba.velocity.x equals this.speed. And in this case, this here refers to this object that we add as a trait. Normally we create classes for these traits, but since I'm just prototyping here, we can just add a trait by just using a normal default JavaScript object. And this syntax is also E6, that you can just write a function inside the object like this. So you would assume that you have to do something like this. But you can actually omit this part, and that will be the same. So let's see if we maintained what we needed now. I'm gonna delete this old velocity here. And we have not defined obstruct. So let's just do that here. Obstruct. Okay, so far, so good. When Goomba walks into the wall, he should change direction. And how can we know if he walks into the wall? I remember something from the jump and Mario mechanics episode. We have the obstruct callback here. And that is called in Tile Collider. So what if we do the same thing for left and right as we do for top and bottom? Let's give it a try. So we're gonna copy this up here. And we're gonna say entity.obstruct sides dot, which is this? X is to the right. That means that we, I think it is left. Wait, I can't think. Yes, if we move to the right, we obstruct on the left. And let's do one of these down here too. And this will be the sides dot right. Actually, I got this wrong. It was the opposite. If I move to the right, I'm gonna obstruct from the right, of course. Of course. And these constants were defined in the entity file. So let's just add them here. Left, symbol, left, right, symbol, right. Then in Goomba.js, we needed to import sides from entity. And when we obstruct, we get the entity. No, sorry, we get the Goomba. We get the side. And if side equals sides.left or side equals sides.right, this.speed equals minus this.speed. So we negate speed. Let's see how we did. Whoo! Isn't that something? Now, let's animate Goomba. Just as we did with Mario here, Mario sprites.json, I'm gonna define the animation in JSON too. So I'm gonna put that in here, comma here, animations, and this is just gonna recall the walk. The frame length is gonna be 0.15. 0.5, yeah, whatever. And the frames are gonna be walk 1 and walk 2. Okay, so this means that we should get out an animation here in the sprites. So console.log sprite. Let's check this out. Animation walk looks good. So we grab it. Const walk anim equals sprite.animations.get walk. And then we call it here. But we need to call it with something. We need to call it with some kind of time. So let's try adding a lifetime to Goomba. So this.lifetime. And now let's attach a little lifetime variable here to Goomba, or property rather. And then when we update here in our little hack trait, we say Goomba.lifetime plus equals delta time. And in the update function, we get delta time out here. So if I got this correctly, this.lifetime property will increase infinitely on the Goomba object. So that means that we will just cycle this walk anim as long as this object is in the scene. Let's see if it works. It worked perfectly. Who would have thought? Who would have thought? This lifetime property turns out that it is so useful that I'm gonna put it on the entity object. So let's delete it from here. And delete it from here. Go into our entity. And we add it as this.lifetime equals 0. And then when we update, we increase lifetime. So this.lifetime. This means that it's now available here. No. Let's check out what happened. Did I save all the files? Save. Oh, I can't set it to 0. I have to plus equals delta time, of course. Now, there we go. That's pretty. Now, let's add a Koopa. And the Koopa is the little green frog here. You might not see. Can I zoom in this application? No. I'm gonna zoom in post. Okay, so Koopa is this little green froggy here. And just as I did last time, I'm gonna take the JSON here. I'm gonna save a new file, koopa.json, and I'm gonna paste in from my notes. This Koopa has the same walk thing here, and I think it actually has the same walk animation too. So let's steal this walk animation from here. We should be able to reuse this. There we go. Cool. And now let's take Goomba.js and save Koopa.js. We're gonna rename all the Goomba references. We say Koopa here instead. And we say Koopa here because that's the Koopa. Because that's the spreadsheet we want to load. I think most other things are good to go. Here we also want to rename. So Koopa there. Let's see if this works. After added to main, of course. So entities dot load Koopa. There we go. There's a Koopa there. Koopa here. And we make it here. We get it here. Create Koopa. I think you get the drill now. And let's copy this. Create a Koopa here. Rename this to Koopa. And put it over, I don't know, 360 maybe. And now we pray to the demo gods that we haven't broken the code. Broke the code. There's a Koopa. It looks a little bit dumb because it's walking backwards. It should be as easy as sending in a flag here. And the flag can be derived from the velocity. This.velocity.x is less than 0. There we go. Walking left, walking right. One thing we should do now is to decouple this code into a trait. Let's cut this out, and I'm gonna open up the jump trait here. I'm gonna save this as a copy of jump and call this pendulum walk, because we're walking back and forth like a pendulum. And we name this to pendulum walk, and we call it pendulum walk here as a name. I'm just gonna delete most of this and almost all of this here. And let's paste this in here and just place everything what there needs to be. The name we have changed, the speed we want to set, just this.speed equals -30. And we have the obstruct call here. We just need to clean up. The update call is here. We put that in here. And we of course doesn't call it Koopa, we call it entity. So entity.side, okay, I think it looks all right. So let's save this trait and go to our Koopa and import it up here. So import pendulum walk from .traits pendulum walk.js. Let's add it to Koopa here. And see how we fare. Nice. Let's do the same for Goomba there. Gonna copy this here. Gonna open goomba.js. And import. Remove the legacy. And instantiate and add. Sweet. So now you can see here that Koopa is walking in the ground. So we need to adjust the height. So I think this is the height here. So let's set that to 24. That didn't work because it's now we have now the Goomba is flying. Did I say Goomba or Bloom? Never mind. Bloomberg. We're gonna call him Bloomberg now. So Koopa is gonna have the height 24. So let's see what he does now. Now he walks on the ground, but I have anticipated a little side effect of this. Let's watch carefully. So he's sneaking here behind. Okay, so not too bad. This is correct behavior for the game, but Koopas are supposed to fit within this area. So I'm gonna go into the entity here, and I'm gonna add an offset. This.offset equals new vec2 and initialize to 0, 0. So offset is gonna be a value for how much the collision rectangle is offset from the position. I'm gonna enable the collision layer to easily understand this. So let's import the create collision layer from .layers.js, and let's add that to the level comp. So level.comp.layers.push create collision layer, and we base this off of level. So now we have collision layers again, and you see here that Koopa, he's taller than this, and we want the Koopa size to be the same as the Goomba size, but we want the rectangle to be lower. So if we set the Koopa size here again to 16, he's walking down in the ground. But if we can move this rectangle down, he would walk on the ground and he would fit within here. So let's start by setting the offset. So Koopa.offset. What is it? It's Y, and it should go down, I think. So it should be -8. It might be upside down. I don't know. We'll see. Equal sign here. And now we need to take the offset into consideration in our code. The place where I'm going to start is in the collision layer. So let's open up our layers module here. And let's take a look at create collision layer. Here, where we draw the entities, we should be able to change the position here to take the offset into account. I'm too stupid to add a lot of numbers together and understand what should happen, but let's have a go. Plus entity.offset.y. Almost. This was opposite direction. I'm not sure if this plus together what happened here actually. Let's set it here. Plus there and see if it changes. This is like, I kind of know how it works, but it's not intuitive. I would never learn this. So I guess if we want this way of writing it out, we need to change it. So minus should be plus or vice versa, whatever. So if we want it to move down, we should have it positively. So this is the way we want it to work. We're now drawing the rectangle at the right position, but we're not using it at the right position where we collide. So let's make the same update in more places. As I told you, I'm way too dumb to do this kind of math. I simply hate adding many numbers together. And the thought of me going into the tile collider here and just writing plus minus plus minus 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 plus 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 and try to keep that in my head with parentheses is obnoxious. So instead, I'm going to introduce a new feature of our entity that I call the bounding box. Let's create a new file and we're going to save that as boundingbox.js. And instead of me typing out this whole class, I'm going to paste this in and explain what it does. So the bounding box takes a position, a size and an offset, and it lets us get and set the bottom, top, left and right properties. And this math that we need to figure out where the left and right and top and bottom actually is, absolutely, will be contained in this getter property here. So when we run bounds.bottom, we will actually get back the result of this calculation. Reversely, if we set.bottom, we will set the position when the difference of the size and offset has been taken into account. So I'm going to save this file, then I go into entity here, import it. Import bounding box from boundingbox.js. And let's add it here as this.bounds equals new bounding box. And we take this.position, this.size, and this.offset. Ah! There we go. There we go. Now, this allows us to, instead of saying all this complicated math there, well, I know this is not that complicated, but I can just say entity.bounds.left here and entity.bounds.top here. So let's try to change the offset on Mario. Where do we have him? Here he is. And just run mario.offset.set and we take something crazy like 24 and 32. Now you can see that we rendered the collision rectangle down here, but we're still calculating with it here. So all we have to do now is go into our tile collider. Where are you? Tile collider. And everywhere we have this annoying crazy math, we're just gonna say entity.bounds.right. This measurement, the position plus the size, is the right side. So all these occurrences are gonna be replaced by entity.bounds.right. Then we have this position plus entity.size.y is the bottom. So we replace this with entity.bounds.bottom. entity.position.y is going to be replaced by entity.bounce.top. And entity.position.x is going to be entity.bounce.left. Now we can remove this extra fixer here in the setter. And we have another airplane coming. So it turns out I live under the airport, flight in path. And it's a lot of airplanes coming landing here in the night. And gonna buy a bazooka. Okay. Bumps obstruct works and offset here works, and the Koopa should be able to fit under the bridge. Well, I'm pretty sure it's gonna work because I can see the debug rectangle here. But let's be quiet and see if it does. Yay! Okay, so now all we have to do is go into the Mario here and remove the offset. We should be back to a nice state here. Here we go. That is one pretty behavior. Now let's take a look at our main.js here. And this looks pretty horrible actually. So let's see if we can improve this. And my proposal is to upgrade this to one load function that returns a factory that can create all our entities. So I'm gonna go in here to the entities file and I'm just gonna remove everything in it. Then I'm gonna create a new function here that I call load entities. Export function load entities. There we go. And this should do similarly to what we do in main. So let's steal some code from here. I'm gonna take these. I'm gonna take the imports. I'm gonna paste them in up here. And I'm gonna return this promise here. Return promise.all. And we're gonna list these in an array. So let's load from this instead. We go into main and we import load entities from .entities.js. And we can run this instead here. We remove the extra calls and then we can actually wrap this in an extra array layer here. So I think this should work. Let's see. Yes, that was the same behavior. But we want to group these creator functions and we want to group them by some name. And I know a really neat trick to solve this. Let's go back to the entities file. So we want to create an object which we can create the factories on with custom names. So let's say here const entity factories and we initialize this as an empty object. Then we can chain here and we get out the factory and we can add it to entity factories Mario equals factory, and let's chain this then on all these two. So this would be Goomba here and this is gonna be Koopa. Then when all promises are resolved we return the entity factory. So we chain then and we send back the entity factory. The entity factories it is even. So now we will get out the factory here. Let's take a look at what the factory looks like. Console.log factory. Now I expect this to blow up. So let's see. Yes, nothing worked actually. Let's go in here again. And what did we go wrong? Yeah, we don't have a comma here that is missing. There we go. Here is our factory. it has Goomba, Koopa, and Mario, and they are the factory functions for these objects. So that means we can now in main write but factory.mario. We can run factory.goomba, and we can run factory.koopa. There we go. But this can now be called entities. Or actually, let's call it entity. And we can do one more nice little thing. We're gonna simplify this part. I'm gonna create a little helper function here that I call function add as, and we got name. And we do something similar to this. We return this same function but with the name bound. So that would be it. So now we can replace all this with a call to add as with a string. And there we go. So now we're in a really good state to continue building this game. So in the next episode, we're gonna look at placing entities inside the level via JSON. Thanks for watching.